Have a look at question 4 and 6 from the mock and see some of these are the questions we found a little bit difficult. So let's see how we go about this one. So the relationship between the rate of change of revenue in millions of dollars per year and the total allocated and the time allocated in business project T in years is investigated. The following table shows some observations. So we've got a table of data. And then we're asked to do the trapezoidal rule. So we're finding the area under the curve. This sort of plots a little bit of a curve. We'll make a little sketch of the curve. Help me sort of understand it. So there's my thing, my time. So it's going to go like this. No, it's not. Sort of goes down, doesn't it? So the curve looks like this. We're making some trapezoids, like that, and then we're finding the area of each of these trapezoids. How many columns does the table have? How many columns does the table have? We got 3 answers to that question. There's 5. How many trapezoids do we have?
4.
Always one less. When we look to the formula sheet, the formula for this one is right at the end, isn't it? The formula for this has this H here. This H caused a lot of problems knowing what H is. This formula here that people tried to use, they didn't really know what this formula meant. So let's have a little look at this one. H is the step size. So it tells you it actually in the question on this one. This is step size, interval width. On this formula, we've got H, we already know it, is B minus A over N. N is the number of trapezoids. N is the number of trapezoids. How many trapezoids do we have? We have 4. So N is 4. B and A, these are the end points. These are the end points. So this is B and this is A. So we've got, if we wanted to use this formula, we've got 0.8 minus 0 over 4, which is 0.2. H caused a lot of problems on this one. The other mistake that a lot of you guys make with this one is the bracketing. So this bracket here is often forgotten. This bracket here is often forgotten. And what you end up doing is a lot of you do a half times H bracket y0 plus yn plus 2 times y1 plus y2 plus ... yn minus 1. So a lot of you do this, which means that only these first 2 terms are getting multiplied by a half h. This is the most common mistake that I see. The other mistake comes from simply not understanding what all of the different numbers are, and particularly over here at the end here, knowing what numbers went in there. I saw the 0.8 coming in there. I saw some confusion on this one. Some people here at the beginning put y1, y2. So the first 2 values went in here. The first 2 values went in here, and then the next 3 values went in here. And they didn't really know where to place them in. So let's see how it should look. And let's see if we can actually calculate the value. So what this does is it calculates the total amount of revenue. So total revenue. So the total revenue, the area under the curve, the trapezoidal rule finds the area under a curve. If you have a function and you find the integral of it, You're sort of summing all of the values that occur during that period. So total value, or the sum of all the values, is what we're getting here on this one. So we need a half times 0.2. Then we need the first and last values, which is which is 2.6 plus 0.6 plus 2 times, and then we need these three values, 3 plus 1.2 plus 1. You've got to make sure you get this bracket in here.
Do we not include the 0.6?
The 0.6 is here.
So what's n minus 1?
What's?
N minus 1.
The n minus 1 is this value here. So from the formula booklet, what this says, y1, that's the first value. So this is the first value. Yn is the last value. Y1 is the second value. Yn minus 1 is the penultimate value. The one but last value, the penultimate value. This is the last value, that's the ultimate value. Doesn't mean it's very good, it means it's the last one. And the penultimate is the one before it. So this is all of the values apart from the two end values. All of the values apart from the two end values. Put it into your calculator, what do we get? Let me do it on my calculator for the people watching the video. When you get your mocks back, I haven't scanned them yet, so I can't return them today. But I'll scan them and then I'll return them to you. When you get your mocks back, one of the things to look to is when you see if you've lost any points by giving an answer in two significant figures.
Okay.
I remember writing that quite a few times. Or rounding errors.
Oh wait, you don't get any more for that?
No. If you don't round correctly, look for rounding errors. I saw more rounding errors than I felt I should have seen on the paper. So look for your rounding errors. Ask me if you don't understand it, but we need to improve on. We can't be losing easy points. We really can't be losing easy points. The other one would be rounding errors caused by you rounding it in part A and then using the rounded value in part B.
Would you not get that?
Yeah, but you still lose a point. 1 point. For one of you people, 1 point will be the difference between a grade, between a 5 and a 6. For one of you. Because there's about 10 points between the grade boundaries. And there's 12 of you in the class. One of you will be 1 point off. One rat, stupid little.
I don't know. What is it?
Have I typed it in correctly?
Yeah.
No, 0.2 equal 2, no? Am I
No.
seeing?
You need to put the bracket.
No, it's 0.2 equal.
Yeah.
Does it look good?
Yeah.
1.36?
That sounds.
Okay. What I was really pleased to see, I can't remember, there was 1 or 2 people couldn't get the answer in this one. So they just put an answer down so that they could get the answer in the next one. I did see that advice followed in a few questions by a few people. If you look at a question and think, I don't really know how to do A, but I do know how to do B, then do something that looks like a method and put an answer down and then use that answer in the next question. make sure your answer is reasonable as well. So this is 1.33, so you want something close to that. When it comes to, make sure you mark which question you're answering like this. Make sure you mark which question you're answering like this. You can lose points if you're not. Not because you don't get penalized for it, but if you've got to make sure your examiner finds what he needs to find. You've got to guide it. You don't want to lose a point because he didn't see it. He thought you were just doing question mark. You won't lose a point for the A and B, but what I'm saying is if you have a bunch of working all over the place, because you guys do, you're not structured as much as I am, and the examiner doesn't see it, he doesn't see, oh, that's the answer to B, he could miss it. So guide them in the right direction so that they find it. When it comes to finding the percentage error, you've got to show this part of the percentage error. You've got to show this part, the absolute function. So we're using the formula from the formula booklet. Most of you know this one, but most of you don't write it correctly.
Is it exact?
It's, so the one that the one that's here on the bottom and the top is the value that is given, the actual value or the exact value. The one at the front is the estimated value, or the one that you calculated. So make sure you put the percentage symbol, times 100%. Make sure you put the absolute value symbol. You're missing these bits and pieces. Type it into the calculator, what do we get? So I can actually type it in using those features. There's the absolute value function. Let's quotient 1.36 minus 1.33 over 1.33. Now on the calculator, you have to times by 100 to turn it into percent. This will give us 2.26%. On the calculator, you times it by 100 so you can write it in percentage, but on your paper you write 100%.